Chapter 5 of Curiosities of the Sky. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Curiosities of the Sky by Garrett Serviss. Chapter 5 Conflagrations in the Heavens. Suppose it were possible for the world to take fire and burn up, as some pessimists think that it will do when the divine wrath shall have sufficiently accumulated against it. Nobody out of our own little corner of space would ever be aware of the catastrophe. With all their telescopes, the astronomers living in the golden light of Arcturus or the diamond blaze of Canopus would be unable to detect the least glimmer of the conflagration that had destroyed the seat of Adam and his descendants, just as now they are totally ignorant of its existence. But at least 15 times in the course of recorded history, men looking out from the earth have beheld in the remote depths of space great outbursts of fiery light, some of them more splendidly luminous than anything else in the firmament except the sun. If they were conflagrations, how many million worlds like ours were required to feed their blaze? It is probable that temporary or new stars, as these wonderful apparitions are called, really are conflagrations, not in the sense of a bonfire or a burning house or city, but in that of a sudden eruption of inconceivable heat and light, such as would result from the stripping off the shell of an encrusted sun, or the crashing together of two mighty orbs flying through space with 100 times the velocity of the swiftest cannon shot. Temporary stars are the rarest and most erratic of astronomical phenomena. The earliest records relating to them are not very clear, and we cannot in every instance be certain that it was one of these appearances that the ignorant and superstitious old chroniclers are trying to describe. The first temporary star that we are absolutely sure of appeared in 1572, and is known as Tycho's star, because the celebrated Danish astronomer, whose remains, with his gold and silver artificial nose, made necessary by a duel, still intact, were disinterred and reburied in 1901, was the first to perceive it in the sky, and the most assiduous and successful in his studies of it. As the first fully accredited representative of its class, this new star made its entry upon the scene without becoming éclat. It is characteristic of these phenomena that they burst into view with amazing suddenness, and, of course, entirely unexpectedly. Tycho's star appeared in the constellation Cassiopeia, near a now well-known and much-watched little star named Kappa, on the evening of November 11, 1572. The story has often been repeated, but it never loses interest, how Tycho, going home that evening, saw people in the street pointing and staring at the sky directly over their heads, and following the direction of their hands and eyes he was astonished to see, near the zenith, an unknown star of surpassing brilliance. It outshone the planet Jupiter, and was therefore far brighter than the first magnitude. There was not another star in the heavens that could be compared with it in splendor. Tycho was not in all respects free from the superstitions of his time, and who is? But he had the true scientific instinct, and immediately he began to study the stranger, and to record with the greatest care every change in its aspect. First he determined as well as he could, with the imperfect instruments of his day, many of which he himself had invented, the precise location of the phenomena in the sky. Then he followed the changes that it underwent. At first it brightened until its light equaled or exceeded that of the planet Venus at her brightest, a statement which will be appreciated at its full value by anyone who has ever watched Venus when she plays her dazzling rôle of evening star, flaring like an arc light in the sunset sky. It even became so brilliant as to be visible in full daylight, since, its position being circumpolar, it never set in the latitude of northern Europe. Finally it began to fade, turning red as it did so, and in March 1574 it disappeared from Tycho's searching gaze, and has never been seen again from that day to this. None of the astronomers of the time could make anything of it. They had not yet as many bases of speculation as we possess today. Tycho's star has achieved a romantic reputation by being fancifully identified with the Star of Bethlehem, said to have led the wondering Magi from their eastern deserts to the cradle manger of the Savior in Palestine. Many attempts have been made to connect this traditional star with some known phenomenon of the heavens, and none seems more idle than this. Yet it persistently survives, and no astronomer is free from eager questions about it addressed by people whose imagination has been excited by the legend. It is only necessary to say that the supposition of a connection between the phenomenon of the Magi and Tycho's star is without any scientific foundation. It was originally based on an unwarranted assumption that the star of Tycho was a variable of long period, appearing once every 315 years or thereabout. If that were true, there would have been an apparition somewhere near the traditional date of the birth of Christ, a date which is itself uncertain. But even the data on which the assumption was based are inconsistent with the theory. Certain monkish records speak of something wonderful appearing in the sky in the years 1264 and 945, and these were taken to have been outbursts of Tycho's star. Investigation shows that the records more probably refer to comets, but even if the objects seen were temporary stars, their dates do not suit the hypothesis. From 945 to 1264 there is a gap of 319 years. From 1264 to 1572, one of only 308 years. Moreover, 337 years have now, in 1909, elapsed since Tycho saw the last glimmer of his star. Upon a variability so irregular and uncertain as that, even if we felt sure that it existed, no conclusion could be found concerning an apparition occurring 2,000 years ago. In the year 1600, the year in which Giordano Bruno was burned at the stake for teaching that there is more than one physical world, a temporary star of the third magnitude broke out in the constellation Cygnus, and curiously enough, considering the rarity of such phenomena, only 4 years later another surprisingly brilliant one appeared in the constellation Ophiuchus. This is often called Kepler's star, because the great German astronomer devoted to it the same attention that Tycho had given to the earlier phenomenon. It, too, like Tycho's, was at first the brightest object in the stellar heavens, although it seems never to have quite equaled its famous predecessor in splendor. It disappeared after a year, also turning of a red color as it became more faint. We shall see the significance of this as we go on. Some of Kepler's contemporaries suggested that the outburst of this star was due to a meeting of atoms in space, an idea bearing a striking resemblance to the modern theory of astronomical collisions. In 1670, 1848, and 1860, temporary stars made their appearance, but none of them was of great brilliance. In 1866, one of the second magnitude broke forth in the northern crown, and awoke such interest because by that time the spectroscope had begun to be employed in studying the composition of the stars, and Huggins demonstrated that the new star consisted largely of incandescent hydrogen. But this star, apparently unlike the others mentioned, was not absolutely new. Before its outburst it had shone as a star of the 9th magnitude, entirely invisible, of course, to the naked eye, and after about 6 weeks it faded to its original condition in which it has ever since remained. In 1876 a temporary star appeared in the constellation Cygnus, and attained at one time the brightness of the 2nd magnitude. Its spectrum and its behavior resembled those of its immediate predecessor. In 1885 astronomers were surprised to see a 6th magnitude star glimmering in the midst of the hazy cloud of the great Andromeda nebula. It soon absolutely disappeared. Its spectrum was remarkable for being continuous, like that of the nebula itself. A continuous spectrum is supposed to represent a body, or a mass, which is either solid or liquid, or composed of gas under great pressure. In January 1892, a new star was suddenly seen in the constellation Auriga. It never rose much above the 4th magnitude, but it showed a peculiar spectrum containing both bright and dark lines of hydrogen. But a bewildering surprise was now in store. The world was to behold at the opening of the 20th century such a celestial spectacle as had not been on view since the times of Tycho and Kepler. Before daylight on the morning of February 22, 1901, the Reverend Dr. Anderson of Edinburgh, an amateur astronomer, who had also been the first to see the new star in Auriga, beheld a strange object in the constellation Perseus, not far from the celebrated variable star Algol. He recognized its character at once, and immediately telegraphed the news, which awoke the startled attention of astronomers all over the world. When first seen, the new star was no brighter than Algol, less than the 2nd magnitude, but within 24 hours it was ablaze, outshining even the brilliant Capella, and far surpassing the 1st magnitude. At the spot in the sky where it appeared, nothing whatever was visible on the night before its coming. This is known with certainty, because a photograph had been made of that region on February 21st, and this photograph showed everything down to the 12th magnitude, but not a trace of the stranger, which burst into view between the 21st and the 22nd like the explosion of a rocket. Upon one who knew the stars the apparition of this intruder in a well-known constellation had the effect of a sudden invasion. The new star was not far west of the zenith in the early evening, and in that position showed to the best advantage. To see Capella, the hitherto unchallenged ruler of that quarter of the sky, abased by comparison with this stranger of alien aspect, for there was always an unfamiliar look about the nova, was decidedly disconcerting. It seemed to portend the beginning of a revolution in the heavens. One could understand what the effect of such an apparition must have been in the superstitious times of Tycho. The star of Tycho had burst forth on the northern border of the Milky Way. This one was on its southern border, some 45 degrees farther east. Astronomers were well prepared this time for the scientific study of the new star, both astronomical photography and spectroscopy having been perfected, and the results of their investigations were calculated to increase the wonder with which the phenomenon was regarded. The star remained at its brightest only a few days, then like a veritable conflagration it began to languish, and, like the reflection of a dying fire, as it sank it began to glow with the red color of embers. But its changes were spasmodic. Once about every 3 days it flared up, only to die away again. During these fluctuations its light varied alternately in the ratio of 1 to 6. Finally it took a permanent downward course, and after a few months the naked eye could no longer perceive it. But it remained visible with telescopes, gradually fading until it had sunk to the 9th magnitude. Then another astonishing change happened. In August, photographs taken at the Yerkes Observatory and at Heidelberg showed that the nova was surrounded by a spiral nebula. The nebula had not been there before, and no one could doubt that it represented a phase of the same catastrophe that had produced the outburst of the new star. At one time the star seemed virtually to have disappeared, as if all its substance had been expanded into the nebulous cloud, but always there remained a stellar nucleus about which the misty spiral spread wider and ever wider, like a wave expanding around a center of disturbance. The nebula, too, showed a variability of brightness, and 4 condensations which formed in it seemed to have a motion of revolution about the star. As time went on the nebula continued to expand at a rate which was computed to be not less than 20,000 miles per second. And now the star itself, showing indications of having turned into a nebula, behaved in a most erratic manner, giving rise to the suspicion that it was about to burst out again. But this did not occur, and at length it sunk into a state of lethargy from which it has to the present time not recovered. But the nebulous spiral has disappeared, and the entire phenomena as it now, in 1909, exists, consists of a faint nebulous star of less than the 9th magnitude. The wonderful transformations just described had been forecast in advance of the discovery of the nebulous spiral encircling the star by the spectroscopic study of the latter. At first there was no suggestion of a nebular constitution, but within a month or two characteristic nebular lines began to appear, and in less than 6 months the whole spectrum had been transformed to the nebular type. In the meantime, the shifting of the spectral lines indicated a complication of rapid motions in several directions simultaneously. These motions were estimated to amount from 100 to 500 miles per second. The human mind is so constituted that it feels forced to seek an explanation of so marvelous a phenomenon as this, even in the absence of the data needed for a sound conclusion. The most natural hypothesis, perhaps, is that of a collision. Such a catastrophe could certainly happen. It has been shown, for instance, that in the infinity of time the earth is sure to be hit by a comet. In the same way it may be asserted that, if no time limit is fixed, the sun is certain to run against some obstacle in space, either another star, or a dense meteor swarm, or one of the dark bodies which there is every reason to believe abound around us. The consequences of such a collision are easy to foretell, provided that we know the masses and the velocities of the colliding bodies. In a preceding chapter we have discussed the motions of the sun and stars, and have seen that they are so swift that an encounter between any two of them could not but be disastrous. But this is not all, for as soon as 2 stars approach within a few million miles, their speed would be enormously increased by their reciprocal attractions, and, if their motion was directed radially with respect to their centers, they would come together with a crash that would reduce them both to nebulous clouds. It is true that the chances of such a head-on collision are relatively very small. 2 stars approaching each other would most probably fall into closed orbits around their common center of gravity. If there were a collision, it would most likely be a grazing one instead of a direct front-to-front encounter. But even a close approach, without any actual collision, would probably prove disastrous, owing to the tidal influence of each of the bodies on the other. Suns, in consequence of their enormous masses and dimensions and the peculiarities of their constitution, are exceedingly dangerous to one another at close quarters. Propinquity awakes in them a mutually destructive tendency. Consisting of matter in the gaseous, or perhaps in some cases liquid state, their tidal pull upon each other, if brought close together, might burst them asunder, and the photospheric envelope being destroyed, the internal incandescent mass would gush out, bringing fiery death to any planets that were revolving near. Without regard to the resulting disturbance of the earth's orbit, the close approach of a great star to the sun would be in the highest degree perilous to us. But this is a danger which may properly be regarded as indefinitely remote, since at our present location in space we are certainly far from every star except the sun, and we may feel confident that no great invisible body is near, for if there were one we should be aware of its presence from the effects of its attraction. As to dark nebulae, which may possibly lie in the track that the solar system is pursuing at the rate of 375 million miles per year, that is another question, and they, too, could be dangerous. This brings us back directly to Nova Persei, for among the many suggestions offered to explain its outburst, as well as those of other temporary stars, one of the most fruitful is that of a collision between a star and a vast invisible nebula. Professor Seeliger, of Munich, first proposed this theory, but it afterward underwent some modifications from others. Stated in a general form, the idea is that a huge dark body, perhaps an extinguished sun, encountered in its progress through space a widespread flock of small meteors forming a dark nebula. As it plunged into the swarm, the friction of the innumerable collisions with the meteors heated its surface to incandescence, and being of vast size, it then became visible to us as a new star. Meanwhile, the motion of the body through the nebula, and its rotation upon itself, set up a gyration in the blazing atmosphere formed around it by the vaporized meteors, and as this atmosphere spread wider, under the laws of gyratory motion, a rotation in the opposite direction began in the inflamed meteoric cloud, outside the central part of the vortex. Thus the spectral lines were caused to show motion in opposite directions, a part of the incandescent mass approaching the earth simultaneously with the retreat of another part. So the curious spectroscopic observations before mentioned were explained. This theory might also account for the appearance of the nebulous spiral first seen some 6 months after the original outburst. The sequent changes in the spectrum of the nova are accounted for by this theory on the assumption, reasonable enough in itself, that at first the invading body would be enveloped in a vaporized atmosphere of relatively slight depth, producing by its absorption the fine dark lines first observed, but that as time went on, and the incessant collisions continued, the blazing atmosphere would become very deep and extensive, whereupon the appearance of the spectral lines would change, and bright lines due to the light of the incandescent meteors surrounding the nucleus at a great distance would take the place of the original dark ones. The vortex of meteors once formed would protect the flying body within from further immediate collisions, the latter now occurring mainly among the meteors themselves, and then the central blaze would die down, and the original splendor of the phenomenon would fade. But the theories about Nova Persei have been almost as numerous as the astronomers who have speculated about it. One of the most startling of them assumed that the outburst was caused by the running amuck of a dark star, which had encountered another star surrounded with planets, the renewed outbreaks of light after the principal one had faded being due to the successive running down of the unfortunate planets. Yet another hypothesis is based on what we have already said of the tidal influence that two close approaching suns would have upon each other. Supposing two such bodies, which had become encrusted, but remained incandescent and fluid within, to approach within almost striking distance, they would whirl each other about their common center of gravity, and at the same time their shells would burst under the tidal strain, and their glowing nuclei being disclosed would produce a great outburst of light. Applying this theory to a nova like that of 1866 in the Northern Crown, which had been visible as a small star before the outbreak, and which afterward resumed its former aspect, we should have to assume that a yet shining sun had been approached by a dark body whose attraction temporarily burst open its photosphere. It might be supposed that in this case the dark body was too far advanced in cooling to suffer the same fate from the tidal pull of its victim, but a close approach of that kind would be expected to result in the formation of a binary system, with orbits of great eccentricity, perhaps, and after the lapse of a certain time the outburst should be renewed by another approximation of the two bodies. A temporary star of that kind would rather be ranked as variable. The celebrated French astronomer Janssen had a different theory of nova Persei, and of temporary stars in general. According to his idea, such phenomena might be the result of chemical changes taking place in a sun without interference by, or collision with, another body. Janssen was engaged for many years in trying to discover evidence of the existence of oxygen in the sun, and he constructed his observatory on the summit of Mont Blanc, specially to pursue that research. He believed that oxygen must surely exist in the sun, since we find so many other familiar elements included in the constitution of the solar globe, and as he was unable to discover satisfactory evidence of its presence, he assumed that it existed in a form unknown on the earth. If it were normally in the sun's chromosphere or coronal atmosphere, he said, it would combine with the hydrogen which we know is there and form an obscuring envelope of water vapor. It exists then in a special state, uncombined with hydrogen, but let the temperature of the sun sink to a critical point, and the oxygen will assume its normal properties and combine with the hydrogen, producing a mighty outburst of light and heat. This, Janssen thought, might explain the phenomena of the temporary stars. It would also, he suggested, account for their brief career, because the combination of the elements would be quickly accomplished, and then the resulting water vapor would form an atmosphere, cutting off the radiation from the star within. This theory may be said to have a livelier human interest than some of the others, since, according to it, the sun may carry in its very constitution a menace to mankind. One does not like to think of it being suddenly transformed into a gigantic laboratory for the explosive combination of oxygen and hydrogen. But while Janssen's theory might do for some temporary stars, it is inadequate to explain all the phenomena of nova Persei, and particularly the appearance of the great spiral nebula that seem to exhale from the heart of the star. Upon the whole, the theory of an encounter between a star and a dark nebula seems best to fit the observations. By that hypothesis, the expanding billow of light surrounding the core of the conflagration is very well accounted for, and the spectroscopic peculiarities are also explained. Dr. Gustave Le Bon offers a yet more alarming theory, suggesting that temporary stars are the result of atomic explosion, but we shall touch upon this more fully in Chapter 14. Twice in the course of this discussion we have called attention to the change of color invariably undergone by temporary stars in the later stages of their career. This was conspicuous with nova Persei, which glowed more and more redly as it faded, until the nebulous light began to overpower that of the stellar nucleus. Nothing could be more suggestive of the dying out of a great fire. Moreover, change of color from white to red is characteristic of all variable stars of long period, such as Mira and Cetus. It is also characteristic of stars believed to be in the later stages of evolution, and consequently approaching extinction, like Antares and Betelgeuse, and still more notably certain small stars which gleam like rubies in the field of the telescope. These last appear to be suns in the closing period of existence as self-luminous bodies. Between the white stars, such as Sirius and Rigel, and the red stars, such as Aldebaran and Alpha Herculis, there is a progressive series of colors from golden yellow through orange to deep red. The change is believed to be due to the increase of absorbing vapors in the stellar atmosphere as the body cools down. In the case of ordinary stars, these changes no doubt occupy many millions of years, which represent the average duration of solar life. But the temporary stars run through similar changes in a few months. They resemble ephemeral insects, born in the morning and doomed to perish with the going down of the sun. End of Chapter 5.